Welcome to Science for Sleep. Tonight, we're exploring one of the most fascinating ideas ever imagined by the human mind. An idea that sits at the intersection of physics, philosophy, and imagination. An idea that feels like science fiction but refuses to stay there. Time travel. Not as a movie plot, not as a fantasy, but as a serious scientific question. Is it theoretically possible to travel through time? To move backward into the past or forward into the future, not by waiting but by motion, by physics, by exploiting the deepest laws of the universe. To understand this, we first need to let go of how time feels. Because time, as experienced by the human mind, is not how time actually works. We feel time as a steady flow, a constant ticking. One second after another, marching forward without pause. The past feels fixed. The future feels open. The present feels razor thin. But physics tells a very different story. According to modern science, time is not universal. It does not tick the same way everywhere. It does not pass at the same speed for everyone. In fact, time is deeply connected to space. Together, they form a single structure called spacetime. This idea comes from Albert Einstein's theory of relativity, and it completely changed how we understand reality. Before Einstein, time was thought to be absolute. A background clock ticking the same for the entire universe. After Einstein, time became flexible, stretchable, adjustable. Time slows down. Time speeds up. Time bends. And under the right conditions, time can behave in ways that feel almost impossible. To understand time travel, we have to begin here, with the realization that time is not what it seems. Einstein showed that the faster you move through space, the slower you move through time. This effect is not philosophical. It is measurable. It has been confirmed by experiments, satellites, and precise atomic clocks. Astronauts on the International Space Station age slightly slower than people on Earth. GPS satellites must correct for time dilation or they would drift out of sync and fail. This means something extraordinary. Traveling into the future is not just possible. It's already happening. If you were to board a spacecraft and travel near the speed of light, time for you would slow dramatically compared to those left behind. You might experience a few years while decades pass on Earth. When you return, you would have traveled into Earth's future. This is not speculation. This is physics. It's called relativistic time dilation, and it is one of the clearest examples of real-time travel allowed by nature. But this only allows travel forward in time. The past is far more complicated. To even ask whether backward time travel is possible, we need to understand what spacetime allows and what it forbids. Spacetime is not a rigid grid. It can curve. Massive objects like stars and black holes warp spacetime around them. This curvature affects how time flows. Near a black hole, time slows dramatically. At the event horizon, time appears to nearly stop relative to distant observers. This extreme warping leads to strange possibilities. One of them is the idea of closed time-like curves. A closed time-like curve is a path through spacetime that loops back on itself. If such a path exists, an object following it could theoretically return to its own past. Einstein's equations do not forbid these paths outright. In fact, certain solutions to the equations allow them. One example is the rotating universe solution proposed by Kurt Gödel. In this model, the universe's rotation allows paths that loop backward in time. Another example involves cosmic strings. Hypothetical ultra-dense objects left over from the early universe. If two cosmic strings passed each other in just the right way, spacetime could twist enough to allow backward time travel. Then there are wormholes. Wormholes are theoretical tunnels through spacetime that connect distant regions of the universe. If one end of a wormhole experiences time differently than the other, due to motion or gravity, the two ends could become offset in time. Traveling through such a wormhole could take you into the past. Again, this is not science fiction. These are real mathematical solutions. But here's where the universe pushes back. Every known method of backward time travel requires conditions that may be physically impossible. Exotic matter with negative energy density. infinite precision, stability beyond what quantum physics allows. Stephen Hawking proposed the chronology protection conjecture, the idea that the laws of physics prevent time travel to the past in order to preserve causality. In simple terms, the universe may not allow paradoxes, because paradoxes are a serious problem. If you travel to the past and change something, you could prevent your own existence. This leads to logical contradictions that physics does not know how to resolve. Some theories attempt to solve this. One idea is the Novikov self-consistency principle. It suggests that any actions taken by a time traveler were always part of history. You can't change the past because whatever you do already happened. Another idea involves branching timelines. When you go back, you create a new timeline. The original remains unchanged. These ideas are popular in fiction, but they also appear in serious physics discussions, especially in interpretations of quantum mechanics. The many worlds interpretation suggests that all possible outcomes exist. Time travel might simply move you between branches rather than rewriting history. Then there are deeper, stranger ideas. Some physicists suggest that time itself may not be fundamental, that it emerges from more basic processes. If time is emergent, then traveling through it might be meaningless in the way we imagine. Others propose that the universe is block-like. Past, present, and future all exist simultaneously. We experience time moving because consciousness moves through the block. In that view, time travel is not movement but perspective. There are also conspiratorial ideas, often fueled by secrecy and classified research. Claims of government time travel programs, the Philadelphia experiment, missing physicists, anomalous experiments with time perception. There is no credible evidence for these claims, but they persist because the underlying science feels so close to the edge of possibility. When science says not impossible, imagination fills the gap. So where does that leave us? Here is the most honest scientific answer. Traveling into the future is absolutely possible and already confirmed. Traveling into the past is not known to be possible, but it is not completely ruled out by the equations of physics. However, every known method faces enormous obstacles that may never be overcome. The universe seems to allow us to glimpse these possibilities, but not to use them freely. And maybe that's intentional. Because time, like sleep, may be something we are meant to move through gently, one direction at a time. As these ideas settle, notice how the question changes. Time travel is not just about machines or physics. It's about how reality is structured, and how limited our perspective truly is. Let's continue by slowing down and looking at time from an even deeper angle, one that physics alone can't fully explain. Because while equations describe how time behaves, they don't explain why we experience it the way we do. One of the strangest facts about time is that the laws of physics mostly do not care which direction time flows. If you watch two particles collide, the equations work the same whether the video is played forward or backward. On the smallest scales, time appears symmetrical. And yet, in everyday life, time clearly has a direction. Memories only form of the past, never the future. Eggs break but never unbreak. Entropy increases. This direction is called the arrow of time. The arrow of time is not built into the fundamental laws of physics. It emerges from statistics, from probability, from the tendency of systems to move from ordered states to disordered ones. This means something subtle but important. The universe does not forbid time travel because of time itself. It forbids it because of entropy. To go backward in time would require reversing entropy, reassembling broken structures, unmixing what has mixed, restoring information that has been lost. On a cosmic scale, this may be overwhelmingly unlikely, even if not strictly impossible. Some physicists believe this is the true barrier to backward time travel. Not energy, not technology, but probability so extreme it might as well be impossible. Then there is quantum mechanics. Quantum systems behave very differently from classical ones. Particles can exist in superpositions. Events are governed by probabilities, not certainties. and time behaves strangely at quantum scales. In some quantum experiments, particles appear to respond to measurements made in the future. Effects seem to precede causes. This does not allow messages to be sent backward in time, but it does blur the distinction between past and future. These experiments suggest that time, at the deepest level, may not be strictly linear. Some interpretations of quantum mechanics treat time as another dimension, no more special than space. Others suggest time emerges only when systems become large and complex. If time is emergent, then time travel might be like trying to travel into a shadow. The shadow exists but only because something deeper is casting it. This leads to one of the most unsettling ideas in modern physics: that the present moment may not be real in the way we think it is. In block universe models, the past, present, and future all coexist. Nothing truly changes. Instead, change is a feature of perception. Consciousness experiences different slices of space-time, creating the illusion of flow. In this view, time travel is not about movement. It's about access. But access may be impossible for physical objects. Consciousness, however, is another question. There are speculative theories suggesting that consciousness might not be bound to time in the same way matter is. That memory, anticipation, and awareness create a subjective experience of time that can stretch, compress, or dissolve. This is something everyone has experienced. Moments that feel endless. Hours that vanish instantly. Dreams that seem to last days but occur in minutes. Sleep itself alters time perception. During deep sleep, time seems to disappear. During dreams, time becomes fluid. Sequences rearrange. Causality loosens. This has led some researchers to wonder whether the brain is capable of experiencing nonlinear time, even if the body cannot move through it. Not time travel in the physical sense, but time travel in experience. This is where science meets philosophy, and where conspiracies begin to grow. Some claim ancient civilizations understood time differently. That myths of gods moving through time were not metaphors, but descriptions of altered states of awareness. Others suggest advanced beings could exist outside of time entirely, observing it the way we observe a landscape. Again, there is no evidence for this. But the persistence of these ideas tells us something important. Humans have always felt that time is stranger than it appears. Even now, with all our equations and experiments, we don't fully understand why time flows forward, why it began, or whether it can end. We don't know whether time existed before the universe or whether it emerged with space. Some theories suggest time began at the Big Bang. Others suggest the Big Bang was a transition from a previous state, with time extending beyond it. If time had a beginning, traveling to before it may be meaningless. If time is eternal, then the past may be infinitely deep. And if time can curve, twist, or loop, then our understanding of cause and effect may be incomplete. What seems clear is this: the universe allows us to move forward in time at different rates. It hints at paths that might loop backward. But it surrounds those paths with uncertainty, instability, and limits, almost as if reality itself is cautious. Perhaps time travel is not forbidden because it is dangerous, but because it would unravel the structure that allows meaning, memory, and identity to exist at all. As these ideas drift through your mind, there's no need to hold on to them tightly. They don't demand answers tonight. They exist to remind us how vast and mysterious reality truly is. Let's keep going by looking at the experiments, proposals, and limits that push time travel from theory toward reality, and then quietly pull it back again. Because one of the most revealing things about time travel is not how close we are to achieving it, but how carefully the universe seems to prevent it. Physicists have tried to design thought experiments that would allow backward time travel without breaking known laws. Again and again, something subtle intervenes. Wormholes are the most famous example. In theory, a wormhole could be created by connecting two distant regions of spacetime. If one end of the wormhole is accelerated close to the speed of light and then brought back, time dilation would cause the two ends to be out of sync. One end would be in the past relative to the other. Passing through the wormhole could allow a traveler to emerge at an earlier time. But wormholes, if they exist at all, are violently unstable. Quantum fluctuations would cause them to collapse instantly. To keep one open would require exotic matter with negative energy density. While negative energy does exist in small quantities in quantum effects, no known process allows it to be accumulated in the amounts required. And even if it could, quantum effects may destroy the wormhole the moment it becomes a time machine. This is where Hawking's chronology protection comes in again. As a wormhole approaches the conditions needed for time travel, quantum radiation builds up near its entrance. This radiation grows without bound, destroying the structure before a closed time-like curve can form. It's as if space-time itself resists being turned back on itself. Another proposal involves rotating black holes. The mathematics suggest that deep inside a rotating black hole, paths through space-time may loop backward in time. But these regions are hidden behind event horizons. No information can escape. Even if time travel occurs there, it is sealed away from the rest of the universe. Once again, access is denied. There are also ideas involving faster-than-light travel. If an object could travel faster than light, it could arrive before it left, according to some reference frames. But faster-than-light travel appears to be forbidden. Not just technologically difficult, but fundamentally incompatible with causality. Every time a loophole appears, a deeper rule closes it. This pattern has led some physicists to suspect that time travel to the past is not just difficult, but fundamentally inconsistent with a stable universe. Not because of paradoxes alone, but because allowing information to flow backward would break the structure that allows physical laws to function. Information, like entropy, has a direction. Once information is created, it spreads. It does not naturally reconverge. Backward time travel would require information to move against its natural gradient. And that may be the deepest reason it fails. Yet there is still an open question. Could time travel occur at scales so small, or in regions so extreme, that its effects cancel out before reaching the macroscopic world? Some physicists think quantum-scale time loops might exist, constantly forming and dissolving within space-time foam. Tiny fluctuations that momentarily violate causality, but average out to a forward-moving universe. If so, time travel might be happening everywhere all the time, but only in ways that leave no trace. This brings us to one of the strangest ideas of all. That time travel is allowed, but only if it cannot be used. That the universe permits violations so small they cannot accumulate into paradoxes. And that may be why time feels smooth even if it isn't. There's also the psychological side. Humans have a powerful intuition that the past is fixed and the future is open. But this intuition may be an evolutionary adaptation, not a fundamental truth. Creatures that perceive time as fluid or reversible might struggle to survive. A forward arrow is useful for planning, learning, and avoiding danger. Our experience of time may be optimized, not accurate, which means our resistance to time travel could be as much mental as physical. That brings us back to dreams. Dreams reorder time effortlessly. Cause and effect dissolve. Events fold into each other. The brain accepts it without question. While dreaming, the mind inhabits a world where time behaves very differently. Some researchers believe dreams are simulations that help the brain explore possibilities, rehearse futures, and integrate memories. In that sense, dreaming is a kind of internal time travel. Not through space-time but through mental states. This doesn't mean dreams are portals or messages from other times. But it does mean the brain is capable of experiencing time in ways that waking consciousness cannot. Which raises a quiet question. If consciousness can move through time subjectively while matter cannot, then what is time really for? Perhaps time exists to allow complexity to unfold, to give cause space to become effect, to allow memory to exist at all. If time could be freely reversed, identity might dissolve. Every choice would lose meaning. Every consequence could be undone. A universe with time travel might be a universe without history. And maybe that is why the laws of physics allow us to think about time travel, to model it, to imagine it, but stop just short of letting us do it. As if the idea itself is the lesson. As these thoughts slow and settle, notice how the question has transformed. Time travel is no longer about machines or equations. It's about why reality is structured the way it is. Why change matters. Why moments cannot be revisited. And why the present, fleeting as it is, holds such power. In the final part, we'll step back and ask the biggest question of all. If time travel is not possible, what does that tell us about the universe, about meaning, and about the role of consciousness within time itself? Let's continue by gently widening the view, stepping back from the mechanics and into the implications. Because when physics reaches its limits, meaning begins to appear. If time travel to the past is impossible, or only allowed in ways that cancel themselves out, then time is not just a dimension. It's a constraint. A rule that shapes everything from stars to thoughts. Time gives the universe memory. Without a fixed past, there could be no accumulation of structure. No galaxies slowly forming. No evolution. No learning. No identity. Every atom carries a history written into its position and motion. Every living thing is a record of countless moments layered on top of one another. Time travel would disrupt that layering, which suggests that the universe may protect its own story. There's a growing idea in theoretical physics that the universe is fundamentally about information, not matter, not energy, information. Black holes, once thought to destroy information, now appear to preserve it in subtle ways. The universe seems to care deeply about information conservation. Time travel to the past would allow information to be duplicated, erased, or rewritten. That may be more dangerous to the universe than any explosion. Some physicists suspect that causality itself is a consequence of information flow. That cause must precede effect because information must have an origin. If information could arrive before it existed, the structure of reality would collapse. This reframes time travel as an information problem, not a transportation problem. You don't just move a person through time. You move knowledge, memory, outcomes. That may be the true reason backward time travel remains out of reach. Then there is the question of free will. If time travel were possible, would choice still matter? If the future can be visited, is it fixed? Some interpretations suggest the future already exists. Others suggest it crystallizes only when observed. Quantum mechanics complicates this further. At the quantum level, outcomes are probabilistic. The future is not determined until measurement. If time travel allowed access to future outcomes, quantum uncertainty would vanish. And without uncertainty, there is no creativity, no novelty, no surprise. The universe might depend on not knowing what comes next, which makes time travel incompatible with the very process of becoming. There are also cultural echoes of this idea. Across civilizations, time is often depicted as cyclical, but rarely reversible. Seasons repeat, but moments do not. Even myths of time travel often come with heavy cost. Memory loss, isolation, unintended consequences. These stories may reflect an intuitive understanding that time is not meant to be mastered. Not because it's forbidden, but because it's foundational. When scientists search for a theory of everything, they are searching for a framework that explains space, time, matter, and energy together. Some candidates remove time entirely from the equations. In these theories, time emerges only when systems interact. If this is correct, then time travel would be like trying to travel through temperature or color. Useful concepts, but not fundamental paths. You can feel warmth change, but you can't step into yesterday's heat. This view suggests that time travel is not missing technology. It's missing meaning. It's asking the wrong kind of question. Instead of asking whether we can travel through time, the deeper question may be why time exists at all. Why the universe chose progression over stasis. Why moments fade instead of stacking endlessly. And why consciousness finds itself moving forward, always forward, through an ever-changing present. From this perspective, time travel is a mirror. It reflects our desire to undo regret, to revisit meaning, to understand origins. Physics can describe limits, but it cannot erase longing. And perhaps that longing is part of the design. As the universe expands, time stretches with it. Moments grow farther apart. Stars burn out. Structures dissolve. In the far future, time itself may lose meaning as nothing changes. At that point, time travel would be irrelevant. Only now, in this era of complexity and awareness, does the question even arise. And that may be the quiet truth. Time travel is interesting not because it might be possible, but because it reveals how deeply time shapes everything we are. And maybe that's enough. We don't need to move through time to understand it. We are already doing exactly that, one moment at a time. And in the next quiet stretch, there's nothing you need to solve, nothing to remember, nothing to change. Just the steady unfolding of now. That's where we'll leave it.